Fine, sir.
Okay, so let's start the session. In the last lecture, we had discussed regular policy method and the uh, procedure to evaluate the answer by using the Newton-Raphson method. Okay, so let us discuss it again. Let's revise this procedure again, formula again, and then we'll discuss some remaining example related to this Newton-Raphson method. So this is a procedure to evaluate the Newton-Raphson formula by using the Taylor series. Okay, we consider one approximate root x0, and then after we'll use the x1 as x0 plus h by adding some small value h to the x0, and we'll get x1, and this will be our exact root, because when we replace x0 plus h to the functions, we get answer is equal to 0. And now consider a Taylor series, that is fx is equal to f of x0 plus h into f of x, f dash x0 plus h square by 2 factorial f double dash x0 up to so on. Okay. And now h is very small, so we can neglect h square, h cube, h raised to 4 terms which are included in the Taylor series. Okay. So which is remaining, fx is equal to f of x0 plus h into f dash of x0. This term will be remaining in the Taylor series. Okay. And h square, h cube, h raised to 4 term will neglect. And now fx is equal to 0 we have, so use it here. So we get f of x0 plus h into f dash of x0, and now h consider as a subject, and replace h as the x1 minus x0 by using this formula, and consider x1 is equal to x0 minus f of x0 upon f dash of x0. This is the first approximation answer by using the Newton-Raphson method. Okay, just need x0 and use it here in this formula. F of x0 means the function output at x0. F dash of x0 means first derivative of the function. Okay, and then replace x0 to the derivative of the function, you will get answer f dash of x0, and simplify that, you will get the first approximation of the given equation. Okay, and similarly we can use here x2 is equal to x1 plus h. Okay, in this starting of the Taylor series, and we can derive the x2 is equal to x1 minus f of x1 upon f dash of x. Okay, so continue this procedure up to the nth iteration. So we can define the general formula xn plus 1 is equal to xn minus f of xn upon f dash of xn. Okay, so this is general formula of Newton-Raphson method. Okay, and just use n is equal to 0, 1, 2, 3, 4, 5, and so on. You will get the answer in form of iteration. Okay, x1, x2, x3, x4, and so on. And then after in this formula, to find the x1 we need a x0. Okay, without x0 we cannot derive the answer of f of x1, means x1 we cannot derive that. Okay, so if it is already given in the example, then use this value as a x0. Okay, and replace in this formula, find x1, then x2, x3, and so on. But if it is not given, okay, if it is not given the values of x0 in the example, then how we can find out that? So first find interval AB where f of a negative, f of b positive, and then you can consider x0 is equal to its average value, that is a plus b by 2. Okay, and this procedure we already know that how we can check f of a, how we can check f of b. Okay, and if it is negative we can consider this is a, if it is positive we will consider as a b, and then after we'll find it average, that will be our x0. And after that we had discussed this example in the last lecture, that is x cube minus 5x plus 3 is equal to 0 by using Newton-Raphson method up to the second iteration. Means we need two iterations to consider the answer of this x cube minus 5x plus 3. Okay, and use x0 is equal to 1, that is already given. So first consider function, that is the derivative 3x square minus 5. Okay, x0 is equal to 1, write a formula xn plus 1 is equal to xn minus f of xn upon f dash of xn. And for first iterations, put n is equal to 0 in this formula. Okay, so formula will become x1 is equal to x0 minus f of x0 upon f dash of x0. And now replace x0 is equal to 1. So it will be 1 minus f of 1 upon f dash of 1. And now f of 1 will be 1 cube minus 5 of 1 plus 3. Okay, so check it answer. And that is f dash of 1 means 3x square minus 5. So replace 1 to the derivative. So 3 of 1 square minus 5. And now simplify that. You will get this is a 1 by 2. And after subtract from 1, it will be the point of 5. Okay, so first iterations of the equation, that is a point of 5. And now use this x1 to find the second iteration x2. So formula of x2 will be replace n is equal to 1 in this formula again. So it will be x of 1 plus 1. So it will be x2 is equal to, here it is x1 minus f of x1 upon f dash of x. And now use x1 as a 0.5 in this formula and check the answer of function value and its derivative value and simplify that. It will be the 0.6471. So it is the answer up to the second iteration 0.6471. Okay, so this is a procedure to check the answer by using the Newton-Raphson method. Okay, we can also consider this tabulated form to define the answer. So let us check this second example. 3x is equal to cos x plus 1. This is a function we have and we'll solve it by using the Newton-Raphson method. Correct up to 4 decimal place. So what is meaning of this line? Correct up to 4 decimal place means here iteration is not mentioned that. We'll check only 5 iteration, 7 iteration and so on. We'll check the answer correct up to 4 decimal place means the two nearest iterations should be correct up to the 4 decimal place. Okay, means after the decimal the 4 value should be correct. Okay, so here function is given that 3x is equal to cos x plus 1. Okay, so consider fx is equal to 0 form. So it will be 3x minus cos x minus 1. Okay, either you can also consider cos x plus 1 minus 3x. That is also correct. Okay, you can also consider this form. Either you can consider 3x minus cos x minus 1. Okay, just consider cos x plus 1 to this side. Okay, shift this cos x plus 1 to this side. So both are positive, so it will be negative here. 3x minus cos x minus 1. So this is a function fx is equal to 0. And now its derivative. So we have 3x minus cos x minus 1. Okay, so derivative of 3x will be 3 and derivative of cos will be minus sign and derivative of minus 1 will be 0. Okay, so 3 derivative of the 3x will be 3 and minus here. And now derivative of cos, okay, it will be minus sin x. That is a simple formula of a differential. 3x will be 3 and minus cos x will be minus of minus sin x. Okay, it is minus as it is here and derivative of cos that will be minus sin. And here minus 1 will be a 0. Okay, it is constant sum. So it will be a 0. So it will be 3 plus a sin x. Okay, so f dash x will be 3 plus sin. It is also required in this formula. So therefore, we have to derive this. Okay, now let's check the example again. X0 is not given here. Okay, the values of x0 is not mentioned in this example. So we'll first derive the x0. And what is the procedure to predict the x0? So first find one interval AB where f of a is negative and f of b is a positive. Okay, first check the two value from the real line. Okay, at this value the function should have a negative output and a second value function should have the positive output. Okay, so I will start with the 0. Okay, check f of 0. So f of 0 will be 3 into 0 minus cos 0 minus 1. Okay, so what is answer of this one? 3 into 0 will be 0 cos 0 and what is output of cos 0? That is a minus 1 and remaining is minus 1 also. So just simplify that, it will be a minus 2. Okay, so answer of f of 0 will be minus 2, that is negative value. And now check f of 1. Okay, replace x is equal to 1 to the equations and you just also verify that. Okay, why it is 1.4597 in your calculator. We have equation is 3x minus cos x minus 1 and let us put x is equal to 1 there. So 3 of 1 minus a cos of 1 minus 1. Okay, consider the radian mode first and then check the answer. So 3 of 1 minus cos 1 minus 1. Okay, so it will be 1.459697. Okay, and just round off up to the 4 decimal, so it will be 1.4597. Okay, because after the 6 there is a 97694 value, so we can consider as a 1.4597. Okay, so answer of f of 1, that is the 1.4597. Okay, and it is a positive value, so our roots lies in between 0 and 1. Okay, so for x0 we can use it average value. Okay, so consider a plus b by 2, and a plus b we have 0 plus 1 by 2, and that will be 1 by 2, and 1 by 2 will be a point of 5. Okay, so we can start our iterations by using the value 0.5. Okay, so let us prepare one table. You can also identify x1, x2, x3 sequentially. Otherwise, you can prepare this table. Okay, first column, that is number of iterations, that second column, that is the values of xn, x0, x1, x2, x3, and so on. Okay, then after f of xn, that is a function output, f of x0, f of x1, f of x2. Then after derivative output, okay, next column will be the f dash of xn, that is the derivative output of the given value. And last column, that is our answer, the formula of Newton-Raphson method. Xn plus 1 is equal to xn minus f of xn upon f dash of xn. Okay, this our required answer, and this column will derive our required answer. Okay, so let's start the first iteration. For first iterations, we'll use x0 is equal to 0.5. Okay, we'll start our procedure by using n is equal to 0. So for n equal to 0, it will become x0, and x0 will be 0.5. Okay, and now function output f of x0 means f of 0.5. So f of 0.5 will be 3 of 0.5 minus cos of 0.5 minus 1. Okay, so that is 3 of 0.5 bracket over minus cos 0.5 and minus 1. Okay, so just check the answer in your calculator. You will get answer minus 0.377582. Okay, so this is value of function output, and so replace it here, that is minus 0.377. And then after the derivative output, so what is the derivative? We have 3 plus sine x. So just find 3 plus sine of 0.5. Okay, so that is 3 plus sine 0.5. Okay, so you will get answer that will be 3.4794. Okay, the derivative output at 0.5, it will be 3.4792. Okay, so this is three value you have: x0, f of x0, and f dash of x0. Okay, so now consider formula for n is equal to 0. So it will be x1 is equal to x0 minus f of x0 upon f dash of x0. Okay, this is the first iteration answer, and you can also write the direct answer without replacing this formula. Okay, you can check the direct value, because all these three value you have, just replace this value in this formula and you will get the answer. So it is 0.5 minus f dash of x0, that is minus of 377, 0.377, and derivative output, that is a 3.4794. Okay, so just check this bracket. There is a 2 negative sign here, so negative will be positive. Okay, so just check 0.5. Okay, in your calculator, 0.5, then after write plus, and then after write bracket 0.377, 0.377 divide 3.4794. Okay, just check this output in your calculator. You will get answer 0.6083. Okay, 0.5, then after write plus. Why it is plus? Because there is a 2 negative sign here. That is a negative that is already defined in the formula, and now values of function output, that is also negative, so it will be positive. Okay, in this final evaluation, so that will be 0.377 divide 3.4794. Okay, just bracket over and check the answer. You will get answer 0.6083522015. Okay, so consider up to 4 decimal because we required answer up to the 4 decimal places. Okay, so that will be 0.6083. Clear? Now in the second iterations we'll use the x1. So x1 we have 0.6083. Okay, so just consider second iterations for n is equal to 1. So xn will become x1 and we have x1 is 0.6083. Okay, and now check it function output. So function we have 3x minus cos x minus 1. So at 0.6083 the function output will be 0.00477. Let us check it. We have 3 of 0.6083. Okay, that is a 3x minus cos 0.6083. Okay, bracket over and minus 1. It is 3x minus cos x minus 1. And now check it output. That will be positive 0.00427. Okay, so just use this value in this as a function output. Okay, so this is the values that we will consider here as a function output at 0.6083. And now verify this one 3.5714. That is the derivative output at 0.6083. So we have derivative of the fx, that is a 3 plus sine x. So 3 plus sine of 0.6083, and that will be 3.5714. Okay, you will get this value 3.5714 as values of f dash x. Okay, f dash of x2. And now the formula of x2, that will be x2 is equal to x1 minus f of x1 upon f dash of x1. That is a formula of x2. Okay, so just replace x1, f of x1 and f dash of x1 to this formula. Okay, so it will be 0.6083. Then after write a bracket here, bracket minus 0.00427 divided by 3.5714. Okay, so just check this value in calculator and verify with the answer. So that is 0.6083 minus, then write a bracket, that is 0.00427 divide 3.5714. Okay, bracket over, you will get answer 0.6071. Okay, that will be 0.6071. Okay, that is answer of second iteration x2. And now we need answer correct up to 4 decimal places. Okay, what is our requirement? Answer should correct up to 4 decimal places. So if we compare x1 and x2, in x1 we have 6083, in x2 we have 6071. So it is correct up to 2 decimal only. It is not correct up to 4 decimal place. Okay, so we'll derive the more iterations to find the answer. Okay, so let us consider x third iteration for n is equal to 2. So xn will become x2 and we have x2 is 0.6071. and now check it function output. 3x minus cos x minus 1. 3 of 0.6071 minus cos of 0.6071 minus 1. Okay, so in calci, okay, without fix button, okay, you will get answer in this form, minus 5.8845 into 10 raised to minus 6. That is also correct answer here in place of this form. Okay, 0.0005888 form. Okay, so this is also correct answer. So how we can derive this answer in calculator? Okay, we need this form as the answer in calculator. So how we can define this answer in place of 10 raised to minus 6 form? So there is one fixed tab, okay, fixed button in your calculator. Just press 3 times mode button, okay, and you will get a fixed SCI and norm. And there is 3 options will be displayed in calculator, okay. Just press 3 times mode button, okay, and you will get 3 options there: fix, SCI and norm, okay. So we need a fix, so just press 1, and in display there is 0 to 9 options will be given, okay. So how many digit is required, okay, after the decimal? So just consider 9 digit, okay. So you will get answer 0.0000 something, okay. Now check this answer again, and you will get this a form in the calci, okay. So that will be 3 of 0.6071 minus cos 0.6071 and minus 1, okay. So it will be now 0.5 times 0.5885. Yes, is it clear this concept? Is there any query, any doubt how we can derive this decimal values form in place of 10 raised to minus 6? Have you got this answer? Because it is also important that how we can use the all option in a calculator to derive our answer very quickly. समझ में आया मैंने क्या कहा? Is it clear to all?
Yes, sir.
Good. Remaining student, have you got this answer 0.000588 in calculator? Good. Okay, this form you can also consider here minus 5.8845 10 raised to minus 6. But when we use this as a function output in the formula, it's take a time to solve it. But in place of that, you can feed this value directly in the calci minus 0.0000588. Okay. So this is important for us also. Okay. So this is a derivative output, and now check it function. Sorry, this is a function output, and now check its derivative output 3 plus sin x. So 3 plus sin x will be 3 plus sine of 0.6071. Okay, and that will be 0.5704888075. Okay, so just round off it 3.5705. Otherwise, you can also consider 3.570488 something. Okay, that is both are correct form. You can consider anyone. And now check x3. You will get answer that is 0.6071 minus of minus 0.0000 times 0 588 divide by 3.5705, otherwise 04. Okay, so just check this, that is a 2 negative sign again here, so just consider positive and add 0.6071. So 0.6071 plus, then after write a bracket, and then write the value 0.0005 times 0 588 divide and 3.5705, okay, otherwise 04, bracket over, and you will get the same answer as the 0.6071. Okay, you will get the answer 0.6071. And now just check the x2 and x3. X2 answer is also 0.6071, and x3 answer is also 0.6071. Okay, so the two nearest iteration are correct up to 4 decimal place. Okay, so we'll stop this procedure and we'll consider the 0.6071 is our final answer. Okay, so is it clear to all? Have you any query, any doubt in this example? Yes, hello, am I audible? Have you any query, any doubt?
No, sir.
Good. So let us check the third one. That is Again by Newton-Raphson method. Function is there x plus sin x plus cos x equal to 0. Okay, what is the function? X plus sin x plus cos x is equal to 0 by using Newton-Raphson method, which is nearer to x is equal to pi. So what is meaning of that x is equal to pi? Okay, the x0 is equal to pi is given. Okay, our roots is nearer to the x is equal to pi, means x0 is equal to pi. Okay, we'll start the iteration by using x0 is equal to a pi. Okay, correct up to 4 significant digits. So what is meaning of that? We will check our answer correct up to 4 decimal place. Okay, significant digit, otherwise 4 decimal place, both has meaning same. Okay, so first we have the function fx is equal to x plus sin x plus cos x is equal to 0, and now we needs its derivative. So let us check its derivative. So x into sin x. So how we can check derivative of x into sin x? What is the rules that we'll use here? D by dx of x into sin x. Okay, so what is the product rule of derivative? What is the product rule of derivative? Does anyone reply? Yes, Uday Raj, what is the product rule of derivative? Dhruvin, Drishti, Eva, Nivya, what is the product rule of derivative? Yes, Uday, can you hear me?
Yes, sir, but I don't know.
That is one formula of diploma in derivative. Okay, remaining student, Nivya, can you hear me, Nivya?
Sir, u dot v is equal to u differentiation of v plus v differentiation of u.
Yes. That is a first function as it is. Okay, if we consider here fx into gx, fx into gx. Okay, and we need d by dx of fx into gx. So it will be fx as it is and derivative of gx. Okay, means g dash x. First term as it is, second term derivative plus now second function as it is, and consider derivative of first function. Okay, this is a rule of derivative. If two functions are in product, then we'll use this formula to find the answer of derivative. Okay, this formula is also important in this method. Okay, should know the derivative of each and every function, because any functions will be given in the example. Without derivative you cannot predict any iteration. Okay, so just remember all this formula at a time, and any formula is required. Okay, in any example. What will be the derivative of any function? So here it is f dash x, that will be x into sin x is given there. So derivative of x into sin x will be x as it is, derivative of sin will be cos x. Okay, and then after sin x as it is, and derivative of x will be a 1. Okay, so that is only sin x here, and then after next term is a cos x, so derivative of cos will be a minus sign. Okay, so that is a minus sin x. So now sin x and minus sin x will be removed, and remaining term is only x into cos x. Okay, so this is our f dash x, x into a cos x. Clear? That is a derivative of the given equation. And now x0 is already given in the example. X0 is equal to pi. Clear? So let's start the number of iterations. Okay, so prepare this type of table. First column there is a number of iteration. Okay, 1 2 3 4. Then after the next column is xn, the values of x0, x1, x2, x3 and so on. Then after the function output f of xn, f of x0, f of x1, f of x2, f of x3. Then after derivative output f dash of xn. Okay, and final one is for our formula. Okay, xn plus 1 is equal to xn minus f of xn upon f dash of x. Clear? So let's start the first derivative. X0 is equal to pi. Okay, we have x0 is equal to pi, that is already given. Okay, and now check it output. Why it is -1 here? That is easy now, because that is a simple standard value we have, cos pi and sin pi. It is a pi into sin pi plus cos pi. Okay, that will be the sin pi is 0 and cos pi is a -1. Okay, so answer is -1 here. And you can also check this answer in calculator. There is a pi is not only 3.14. Okay, now just remember that. Just not replace 3.14 only value as a pi. You can use the full values of the pi in the calc. How we can use that? There is one exp tab. Okay, in the last row, nearer to the answer. Exp tab. Okay, so in there you can use the shift exp tab to check the values of pi. Okay, press shift exp. Okay, exp, there is a one button is given in the last row. Okay, in the scientific calculator. So use this exp tab. Okay, by using shift exp, and you can use the pi value. Okay, in calculator. So use this form to find the sin pi, cos pi, and remaining all the term. Okay, so x0 is equal to pi, and then after we can check sine f of pi, and that will be the -1. Okay, and now check f dash of pi. Okay, so it will be pi into cos pi. So cos pi we have -1, and pi it is in product, so it will be the minus pi. Okay, that is a pi into cos pi. Okay, so that will be the -1, pi into -1. Okay, pi as it is, and cos pi का आंसर क्या है हमारे पास? There is a -1, so it will be the minus pi. Okay, so it is a minus pi, and now this one, x0 minus f of x0 upon f dash of x0. Okay, so x0 we have pi, f of x0 that is a -1, f dash of x0 that is a minus pi. So use it here now. Okay, and check it output. So you just consider pi. Okay, that is x0 minus, that is -1 upon pi. Clear? F of x is a -1, and f dash of x0 it is minus pi. So you will get this form in calculator, and then after consider pi plus 1 upon pi. Okay, you to derive this form pi, and that is minus minus plus 1 upon pi. You cannot consider 3.14 only values of pi. Okay, consider, use the pi button, means the pi output that is given already in the calc. So consider shift exp. Okay, then after write a plus, pi will be displayed in calc, and then you can use the bracket to define 1 plus, again use the shift exp tab and consider pi again, and then a bracket over, and it will be a 3.4 that is a pi x0, that is f of x0, and 1 upon pi. It is -1. Okay, there is a 2 negative sign here. Okay, there is there is also minus pi here. Okay, so remaining is a negative here. Okay, there is a 3 negative sign is given there. Okay, that is a -1 minus pi and 1 negative sign for the formula. Okay, so that will be pi minus 1 upon pi, pi minus, then after write bracket, write a 1 divide 1 upon pi. Okay, so that you will get 2.82328. Yes, so got this answer in calc? Does anyone have any query? Yes, how many of you got this answer? 2.82328 in your calculator. Panel, Hers, Hetal, Eva, Umang, Zubair. Yes, what about remaining student? Janice, Keval, Kunal, Dinesh, Ayushi. બધા પાસે કેલ્ક્યુલેટર છે ને પહેલા તો? Good, chalo. So try it and verify this answer also in calculator. Okay, step by step. So that you will get 2.82328. Okay, that is our first iteration by using Newton-Raphson method, and that is called x1. And now in the second iterations, we'll use the x1 is equal to 2.82328. Okay, this is the iteration. And now check the function output, and that will be minus 0.06618, and verify it by yourself. Okay, in calculator. So x sin x plus cos x. Okay, this is a function, and 2.82328, this that is the value. Okay, so replace it here and check f of 2.82328. That will be 2.328 into sine 2.82328 plus cos 2.82328. Okay, that will be formed. Is 2.82328. Okay, then after sine 2.82328. Okay, bracket over, and after plus cos 2.2328. Okay, bracket over, and that will be negative 0.06617. Okay, that is the answer. Okay, so there is minus 0.00 6617 something, so you can consider it round off value as the 18. Okay, that is correct. And then after check it derivative output 2.82328 into cos 2.82328. Okay, so just verify this value with calci. It is 2.82328 into cos 2.2328. Okay, and then check it answer, you will get minus 2.68145. Okay, that is the answer of derivative, to minus 2.68145. And now check it function output, means x2. So it will be 2.82328. Okay, that is the values 328 and minus. Now again we have two negative sign here. Okay, and one negative sign for a derivative, means for formula. So remaining is the negative. Okay, so 0.000618 divide by 2.68145. Okay, 0.06618 divide 2.68145. Okay, so just check this and verify your answer with that 2.7986. So we got this answer 2.79, 2.79. Okay, then after in Kelsey you will get 8599324. Okay, this number will repeat 2.7985999324, and you can consider a round of value up to the 4 decimal. So here it is 99324, so we can consider here 86. Okay, and you can also consider 85. This no worry about that, you'll get the same answer at last. Okay, but it's take one more iterations, I think. So consider 86, 2.7986, that is the answer of x2. Okay, so use it here to find third iterations 2.7986, and now verify this value, x into sin x plus cos x. Okay, this answer you will get minus 0.00056. So function output at 2.7986. Replace 2.7986 into sine 2.7986 plus cos of 2.7986. Okay, and we'll get this value in the radian mode of the calculation. And then after check its derivative output, x into cos x, and replace this 2.7986 to the x into cos x. Okay, so that will be minus 2.635559. This value you will get. And now check its output here as a x3. So x3 will be 2.7986. Now check that there is a 2 negative sign in the denominator and numerator. Okay, and 1 negative sign for the formula. So remaining will be negative. Consider the negative sign. 0.00056 divided by 2.63559. So check this answer and reply it in chat box. How many digits you will get after the decimal? Yes, what is the answer of x3? Janice, what is the answer? How many digits you got after the decimal? Ayushi, Janice, Dinesh, Viswa, Ayush. Okay, are you trying or not? Okay, good. Okay, so it will be 2.79838750. Is it correct? 2.7983 2.79835 yes, 2.798387520. This value you will get in the calci, and you just consider it round off value up to the 4, otherwise 5 decimal. So here I consider 2.7983, and it is 87520, so we can consider as a round of 9. Okay, so 2.79839. So it is x3, and now check again x4, because we required answer correct up to 4 decimal place. So if we compare x2 and x3, so it is correct up to 2 decimal, 2.79, 2.79. Third value is a 8, so it is correct up to 3 decimal. But in the fourth value, that is here 6, and here it is a 3. Okay, so it is not correct up to 4 decimal place. So let us derive another root, x3, that is 2.7983, and you will get the function output at 2.79839. Okay, just verify this value minus 0.0001 with your answer. That is 2.79839 into sine 2.79839 bracket over, then after plus cos 2.79839. Okay, so it will be that is 10 is more here. Okay, that is minus 0.839 sine 2.79839 plus cos 2.79839. Okay, so add one more zero here. It is a 0.4 times 0, then after 104 something. Okay, that answer you will get and function out. And now check this one, minus 2.6359. So 2.79839 into sine 2. Cos to cos 2.79839. Okay, so that will be minus 2.63519. That is the correct one. Okay, and now check this one, you will get this answer 2.79839. Okay, so now the 4 digits are matched after the decimal. Clear? So we'll stop our procedure and we'll consider the answer for this method, for this equation, that is a 2.798319. Okay, so that is the our required answer, 2.7983. And then fourth one, this is for your practice, try it by yourself, and we'll take the answer in the next lecture. Just write down this data, and we'll also consider which method is suitable. Okay, right now we are learned the 3 method, bisection, regular Falsey, and this Newton-Raphson method. So just try it by yourself. X is equal to cos x by Newton-Raphson method, correct up to 3 significant digits, and we'll verify your answer in the next lecture. This example we had already solved in the bisection method. Okay, x is equal to cos x, and it's required 11 iterations to predict the answer. But in this method, it's required less iteration. I think 4 to 5 iteration is required to derive your required answer. Okay, so just try it by yourself. Okay, just practice it, and we'll check. We'll verify the answer in the next lecture. So, have you any query, any doubt to anyone? So please ask me. Otherwise, we'll take the attendance and then conclude this today's session.